So in the previous video we had set out the relationship between DIR, debt service to income ratio, and household expense to income ratio, and then we broke that across the different credit scoring, right, levels. So the CCS. So if we see where we get this from, if we run that segment of code, this is what appears. Okay, so we filtered our data. We took the all data and then we said, look, filter so that we only include values, observations, rows that have DIR less than 1, and then run the ggplot, and we produce a scatter graph. So the G point is a scatter graph, and then the aesthetic is on the x-axis. We have the debt service to income ratio to household on the y-axis, household expenses to income ratio, and then we break across the different facet wrap, the credit scores of 1, 2, 3, 4, 5, 6. We break across those. Was the applicant, each dot represents an applicant here, was the applicant successful, so the no means successful in obtaining the mortgage, or did they fail in getting the mortgage? So yes, the no would mean they failed to get the mortgage. When we look here at 1 and 2, what we observe is predominantly red. That means being successful in getting the mortgage application. If the debt to income ratio, debt service to income ratio, or debt expense to income ratio is less than perhaps 0.5 or maybe 0.4, so predominantly red. And then on the household income, perhaps once we go below 20%. Now that these are not completely scientific, but these are kind of broad brush observations that visually we might see as being relevant, particularly when we start looking at the conditional inference trees that Halvarian implements a little bit later on with some additional code that we will go through. Likewise here for credit score 2, the distribution more to the left and more down is more, we have more red, and the further we go in this direction, the more blue. So the higher the DIR, the higher HIR, perhaps the more blue. In other words, the more mortgage applications that were denied. Once we go to credit score 3, 4, 5, and 6, we probably can't draw lines as clearly. And again, that serves to reinforce all these variables interact with each other. So the DIR, the HIR, and the credit scores are all linked to each other and all conspire to produce outcome that predisposes to either being denied the mortgage or where the mortgage is approved. So opposite to deny is mortgage approval. Okay, is the relationship between the DIR and HIR? We can run a basic correlation and we can see that it is quite high, and of course that's 0.78. That's in part driven by underlining each of these in the denominator for HIR, and DIR we have income at the base. So there's that may not be too surprising, that result, but we can observe, yes, they're highly correlated to each other. We might like to do something a little bit more fancy in terms of just graphing and visualization. I've included here GM smoothing. So if we look at our ggplot2 syntax, I take the data set all, which is, if we want to look at that data set is the 2,380 observations of the 13 variables, and we and then we filter for DIR being less than 1, so we exclude all the observations, all the rows where DIR is 1 or more, and then we run the ggplot. It's a scatter graph, so gene point is a scatter graph. On the horizontal axis we have loan to value ratio, and on the vertical axis we have debt expense to income ratio. We color each point, so each applicant then is given a color. Blue here denotes that they failed to get the mortgage or were unsuccessful as applicants, and red indicates they were successful in obtaining the mortgage. We facet wrap as before by credit scoring, so we break apart the best credit quality from the most inferior credit quality. And in this instance, I've put in a GM, a smoothing relationship between the two. It doesn't really provide us with any clear guidance. Perhaps the what we might observe here is, and what we might expect, that as the loan to value ratio would increase, then the debt to income ratio should increase as well, so that the higher the amount of loan we've got to support given any value for a property, then we might expect that this has a positive correlation with the debt to income ratio. It's also because okay, and just to observe that, we could run that correlation and it's just slightly positive, 0.15. We could do box plots where we compare the range of values, the first quartile, the third quartile, the median for those who are denied, and on the horizontal here we have either been successful and those who were unsuccessful in their application for this box plot, and then on the vertical axis we're comparing the debt expense to income ratio, and there seems to be some evidence to suggest that those with a higher debt expense to income ratio more likely to be rejected in terms of the mortgage. So mortgage deny, yes, typically they did have higher debt expense to income ratio. So some marginal evidence, but not compelling, but some marginal evidence here to support the view that debt expense to income, the greater that becomes, the more likely it would appear that the individual's mortgage application is rejected. Okay, so there seems to be consistency there. And we could then break that apart, again using a facet wrap, where we base each individual graph within the unified graph on the credit score, and we could examine the DIR level for those who are successful and those unsuccessful, successful, unsuccessful, successful, unsuccessful. Each instance there seems to be evidence that the DIR tended to be higher on those who were unsuccessful. We could then, just for better visibility, exclude those observations where DIR is greater than 2. There's only one here that I can see, so we knock that out, and that's just to improve our own optics. And again, it becomes clear that there is a difference between those who are rejected and those who are accepted in terms of mortgage. DIR tends to be higher for those who are rejected. Okay, so we could use some more ggplot and compare the loan to value ratio. Again, we saw some evidence to suggest that the loan to value, increasing loan to value, presents particular risks to banks, and when we compare those applicants that are again credit score 1, 2, 3, 4, 5, 6, we can see that the loan to value ratio for those who are rejected, typically their loan to value was a bit higher. So the banks perceive this perhaps as a risk and are less predisposed to make a loan to those with these higher DIR. Now again, the range is what's probably interesting here. Many people with very low loan to value ratios also rejected. Okay, so we can kind of see that somewhat. It's not that if your loan to value ratio is low, you automatically were approved the mortgage. In fact, no, we have evidence here that many were in fact rejected with low loan to value ratios. So it's not conclusive, but when we compare medians and quartiles, first quartile, third quartiles, loan to value ratio is, the higher that is, the less willing banks would appear to want to lend. Again, we could do something similar, but this time we could color code so that we have, for those who are self-employed, and what this does then is introduces another element here, how do self-employed people stack up against those who are employed. So let's run. So we're getting the same graph, except now we have those who are employed, so the red, and those who are self-employed, which are the blue. And when we look at the loan to value ratio, those who were approved tended to have lower loan to value ratio. So if you're self-employed, the LVR here, which is on the vertical axis, would appear to be lower. Not conclusive, would appear to be lower. Those who were accepted for mortgages, the no, not denied, then their LVR was tended to be lower. So comparing here and here and here, right? So again, these are just glimpses at a certain type of reality. It may be difficult to substantiate those patterns, but they provide us with clues, and that's what exploratory data analysis really means, that we look at the data in a kind of open-minded fashion, and we try not to introduce too much our own a priori impressions, and that with a slightly free perspective, try to observe, well, what are there any trends here? Okay, so again, we run some more analysis. This time we're going to look at not those who are self-employed. We're going to try and break apart the LVR and look at people who were African American compared to all the others, and compare the LVR. If there was discrimination, we might expect that if there was credit rationing, the LVR on African Americans would be more stringent. So let's just run and see what happens. And interestingly, what we notice, those individuals who are black, yes, African American, or otherwise, no. African Americans seem to have a higher LVR compared to their peers for those who were approved. So this group on the left hand side, no, means no to deny, successful in their mortgage application. For African Americans, yes, the blue, the LVR is higher. So in the next video we will continue with this and consider it a little bit more.